Hey everyone, welcome to Refactor. In this video, we'll be learning about one of the very basic sorting algorithms which is called as bubble sort. In this video, we'll be learning about how bubble sort works, how to calculate complexity of bubble sort, and then we'll be writing the code of bubble sort in Java. So let's start learning. So let's understand with the help of an example. We have a list of elements present in random order and we need to sort them in ascending order. And now we'll see why bubble sort is called bubble sort. So first we'll solve this problem and then try to understand why we named it as bubble sort. There are multiple iterations that are performed in bubble sort, and with each iteration one element reaches its correct position, and all that would be happening towards this first or the end, towards the starting. So let's try to understand. So next we'll try to understand why bubble sort is called bubble sort by solving this problem. To understand bubble sort, one thing that we need to know is that with every iteration, one element of the array would reach its correct position. If we are solving the array in an ascending order, so with every iteration, the largest element inside this array would be reaching its correct position. So for example, in my first iteration, bubble sort would be able to identify that 44 is the largest element and it would push the element to the last position after the first iteration. And also, so basically there are two things to keep in mind while implementing bubble sort. The first thing is, with every iteration one element reaches its correct position, and with every iteration the size of the array in which we need to perform sorting reduces. So if in the first iteration we parse the entire array of n elements, in the second iteration the number of elements would be n minus 1, because one element is already at the correct position. And after the second iteration, the number of comparison or parsing would be of element of array of size n minus 2, because two elements would be at their correct position. So let's solve this one by one, and then we'll get to know why bubble sort is called bubble sort, and we'll understand this algorithm better. So in the first iteration, now in the first iteration the pointer would be pointing at 23. And once the pointer always compares its value with the next element. So 23 would be compared with 5. Out of 23 and 5, 23 being the largest, so we would be swapping these two. So the array becomes now this is the second parsing of the first iteration. The first iteration is only containing the first iteration would start from the first element and will go to the till the end. So now our pointer has come at this side. We'll compare its value from the next with the next element, and again it is larger than the next element, so our array would become, and our pointer would move here. So if we just compare the values here, pointer is at 0, I equals to 0, and let's call this j becomes 1 over here, j becomes 2 over here. Now a pointer is at 23, and again it will compare its value with the next element, which is 20. Again this pointer value is greater than 20, so we would be swapping them. Now the array would become, and a pointer moves to the next element. Similarly in the next, but in this case it will be comparing its value from 41, which is not greater than our current value. So we won't be doing any swapping, but our pointer will move to the next element. So here comes the bubble. And again we'll do a comparison between this element and the next element. And our array would become right, and the bubble comes at this element. Now since we've reached the end of the array, this iteration completes at this point. So if you notice, in this complete iteration, firstly we have done the comparison n times, that is n equal to array's length. And if you just see this, there's a bubble that is starting from the start of the array and is reaching till the end of the array. And after the completion of one iteration, this element, as we spoke about before, has reached is the largest element and has reached its correct position, which is at the end of the element. So this has reached correct position. Now similarly, our next iteration would be performed, but there are two things to note while we are doing the next iteration, just to remember what happens in bubble sort. First one is, in one item. So basically, in one iteration, the largest or the smallest element reaches its correct position towards the end of the array. We've said largest or smallest because that depends on whether we are sorting it in ascending or descending order. And the second point to note about this is that with every iteration, the size of the array in which we need to do the sorting reduces. Now these 2 points are very important in understanding bubble sort, and keeping these in mind, we'll be solving the next iterations. So if we go over here, this was how we solved it. This was the first iteration. Now our array looks something like this. And we know that the element at the last position is already sorted. So now we'll be iterating only till n minus 1. And if we since array would be array that we use is 0 indexed, so this element is usually considered at n minus 1. So this time it will be n minus 2. So let's do it. We'll be comparing these two. So in the first iteration, the array would look like this. In the first round of the second iteration, our array would look like this. Then there would be a comparison between these. They are already sorted, so there would be no swapping. The pointer would move to the next element. Now again, there is no sorting required. The pointer would move to the next element. And here the next element is smaller than our current pointer, so here the swapping would happen and the bubble would move to the next element and the pointer lies here. Again, as we saw, our the last element was already at the last position. Again, the second largest element has reached its correct position, which is the second largest position. Similarly, we do it for all of the elements. And if you notice, this time we did only till here, that was n minus 2th position. Now, we would try to understand it in terms of variables that we would be using it for coding. So, if we understand it, there are two pointers, two variables being considered over here. One is the variable which is taking care that we only, after every iteration, one element reaches the end of the position. Basically, one element is taking care that we do not parse the entire array. We parse n minus something that is the count of the iteration we are on. So basically, in first iteration, which is zeroth index, we parse n elements. In zeroth iteration, we parse n element. In oneth iteration, we parse n minus 1 element. In second iteration, like you can index it whichever way, it will go to n minus 2 and so on. So there is one variable taking care of this iterations, we can call it I, and then there is a second variable which is taking care of the bubble that is iterating across the array, which is this. So let's call it J. So as we see, there are two pointers moving and they are dependent on each other. So J iterates only till n minus ith position. So do you kind of see a nested array in this entire solution? So one, we are iterating from ith equals to I less than n, and every time I is increasing, and there's a second loop which starts from 0 but it is going till n minus I, and again it is also increasing. So this is what defines how a bubble sort is executing. I hope I made that clear. In case you still have any doubts, maybe you can put your questions in the comment box and I'll try to answer that as soon as possible. Now let's write some code for bubble sort. As we saw that there would be two variables involved in sorting the array using bubble sort. So we would be using I comma j as the variables and we'll be coding the solution in Java. So let's get started. We'll be starting a for loop where we specify the first variable that starts from 0th index because our array is 0th indexed, and I will be moving till the length of the array. And since we've used less than, we can choose length of array. If we choose less than equal to, then we'll have to do length of array minus 1. And I plus plus. This is the first loop that we add. Now we'll start the second loop, which goes like this. We've taken the second variable as j. Now j would be less than input of length of the input array minus I. Now this is something that is important to be considered, that we talked about earlier as well. I hope you have understood this. In case there are still any doubts, you can post your question in the comment box and I'll try to answer them. Now the first thing that we need to do is we need to compare the two elements. So we have to compare the first element and we have to compare the next element. Okay, there's also another thing that we need to take care of here. Since we are comparing the next element with the current element, so there would be a situation when we'll be reaching the end of the array and then we would be trying to compare it with the next element of the array, which won't exist, and we'll be facing index out of bound exception. To avoid it, we'll only traverse the array in this loop till input of length of the input array minus I minus 1. So we would move only till the second last element, we will not go to the last element. So this is that. Now we'll see if input of j is less than, we'll say greater than. If it is greater than, then we'll just swap them. We'll put them in a temp array and then we'll put the jth element there. Okay. So here we swapped it, and that is all. That is all that needs to be done. Right, so let's just go ahead and run this. Right, so this was the array that was given in the question before sorting, and after sorting this is what we get. So that was the code. So now let's talk about the complexity of the solution. So if we have a look closely at the array, for the in the very first iteration, there are n comparisons that we are doing. Basically, we are accessing n elements. In the second iteration, we are doing n minus 1, because as we said that in every iteration, the largest or the smallest element would reach the correct position, that is at the end or the start of the array. So every time there is one less number that we have to compare. So for the second type it will be n minus 1, then n minus 2, and so on. And in order to calculate the complexity, we'll have to add all of these. So we'll do n plus n minus 1 plus n minus 2, and if you observe it carefully, then this is almost equal to the linear sum of n element. And if you remember the maths formula for this, that is n into n plus 1 by 2. So this is the math formula. So if we convert it, it would be n to the power 2 if n is too large. And that is how we conclude that the complexity for bubble sort is O n of square. So that's the complexity of bubble sort. So that is all for today's video. I hope you got to learn something from it. If you did, please do share it with your friends, and if you want to see similar content in future, please do subscribe to the channel, because we have a lot coming in the future. Thank you so much. Bye bye.